MCP matters because capable models still fail. Context arrives as pasted fragments or brittle plugins. One-off API glue doesn't scale either. Model Context Protocol standardizes connections. It links AI apps to external systems and data. Tools and workflows integrate seamlessly. Claude IDEs and custom agents use governed context. No more guessing from memory. The strategic shift is simple. Context becomes infrastructure, not just chat decoration. Timing matters now. Every serious AI product hits this wall eventually. Integrations don't scale linearly over time. Each model needs access to documents, databases, and SaaS tools. It also needs to connect to code bases and internal workflows. Without a shared protocol, every link becomes custom middleware. Permissions get duplicated across each connection. Maintenance turns fragile and hard to manage. The real bottleneck isn't intelligence. It's delivering safe, reusable context across many apps. Teams feel this pain right away. The root cause is context was treated as text, not as an operating layer in the system. Files were uploaded, APIs wrapped, retrieval bolted on, tool calls hidden behind application-specific contracts. That architecture works for demos, but production systems need discovery and schemas. They need lifecycle management and authorization, and they require auditable execution. MCP formalizes that missing layer. For modern AI software, that is the inflection point. The breakthrough isn't another agent framework. MCP is a protocol boundary between AI hosts and external providers. Anthropic introduced it as an open standard. It enables secure, two-way connections between data sources and AI tools. Developers can expose systems via MCP servers. They can also build MCP clients inside AI applications. The integration surface becomes standardized. No need to reinvent it for every product. The architecture has three visible zones. A host is the AI application you interact with. A client runs inside the host. It manages one connection to a single server. A server provides access to external system capabilities. The base protocol uses structured JSON RPC messages. It handles lifecycle negotiation and feature discovery. It supports cross-cutting utilities for consistency. The model focuses on capability exposure. The system maintains clear boundary separation. MCP servers expose three core primitives. Each primitive solves a distinct problem. Tools are executable functions the model can invoke. Examples include database queries and API calls. Resources are URI-addressed context like files. They also include schemas and application data. Prompts are reusable templates and structured instructions. They guide specific workflows effectively. Together, they separate action, information, and guidance. This creates clean architectural lanes. This is the mental model. The workflow is a controlled handshake. It's not a magic plugin. The host starts a client. The client initializes a session. Both sides negotiate capabilities. The client discovers available tools. It also finds resources and prompts. When the user asks for a task, the model selects context or proposes a tool call. The server executes only the requested capability. It returns structured results. Nothing runs outside that path. This changes how application teams design AI. Instead of embedding every tool in every assistant, teams publish capabilities once. Compatible clients can then discover them. A finance server exposes invoice lookup. A code server exposes repository context. A support server exposes ticket workflows. The assistant becomes lighter. The environment becomes legible, modular, and replaceable. Ownership shifts to the platform. Security is the product. The security model must be explicit. MCP connects language models to real systems. Tools represent arbitrary code execution risk. Hosts must get explicit user consent first. User data needs proper access controls. Authorization is critical for user-specific data. Enterprise auditing requires strong safeguards. API consent must be managed carefully. Rate limits protect system integrity. Sensitive operations that change state need strict controls. The production pattern uses layered control. Start with least privileged servers. Use narrow tool schemas. Set read-only resources by default. Use prompt templates that encode approved workflows. Add OAuth-style authorization for remote servers only when touching private data. Log every tool call. Record resource reads, track parameters used, capture approvals, store returned outputs. MCP doesn't remove risk. It makes the risk inspectable before scale magnifies it. Governance becomes part of design. The impact is architectural compression. MCP turns separate integration projects into a shared capability ecosystem. One server can serve multiple AI clients. One client can connect to multiple servers without rewriting connectors. This means faster pilots and cleaner governance. It also enables better separation between model behavior, business logic, and data access. Context stops being a feature, it becomes a platform layer. The future operating model is not giving the model everything. It's context routing with consent. The teams will design MCP servers like APIs with stable contracts and clear permissions. They'll include observability and versioned capabilities. The winning AI systems won't be the loudest assistants. They'll be the ones that know exactly what they can access, when they can access it, why they're accessing it, and under whose authority.